In this teaching worksheet, we are going to explore some the conditions for a quadratic function to be positive or negative. Okay, and we'll be also exploring the concept of simultaneous equation and how is the discriminant being implicated in the idea of simultaneous equation. So that will be the main idea for this teaching worksheet. So let's explore the idea for the condition of a quadratic function first. Okay, so this is always a very, very confusing idea. So, okay, so this is a quadratic function. So when we say a quadratic function is always positive, it's different from discriminant being positive. So don't get the wrong idea. So I'm going to go slow. So when we say a quadratic function is always positive, this is the meaning. The meaning will be the curve is entirely above the x-axis. Okay, so this is the idea. When a quadratic function is always positive, this is the implication. The curve is entirely above the x-axis, and visually, this is how it looks like. Okay, so do not be confused with discriminant being positive. So discriminant is positive, is implying about the real and distinct roots. Okay, so don't always think about always positive, always positive. You got to be thinking, is it the discriminant being positive or is it the quadratic function being positive? So in our case here, it is a quadratic function being positive. So the implication will be the curve is entirely above the x-axis. So what are the conditions for this? So the condition will be A has to be positive. A is the coefficient of the x squared. Why does it need to be positive? Because only when A is positive, you will be getting a smile graph. So this condition for A positive is to ensure that you got a smile graph. And why do you have a discriminant being negative? Because if you look at the graphical idea, you realize that there are no roots. There are no intersection with the x-axis. So that's why it's essentially no roots. And this is exactly the condition for no roots. So there are two conditions. Okay, so subsequently, if we mention that a quadratic function is negative. Okay, so let me use another color. Okay, I shall use a green color. So this function, a quadratic function is always negative. So when a quadratic function is always negative, the meaning will be the graph is entirely below the x-axis. So this is how it looks like. A graph is entirely below the x-axis. So when a quadratic function is always negative, the real implication will be the graph is entirely below the x-axis. So what are the conditions for this? So the condition will be A negative. A negative will ensure a set face graph. So A negative will ensure a set face graph. And as you can see here, okay, there are no intersection with the x-axis. So again, this is no roots. So in this situation, there is no roots. So that's why the discriminant is negative due to the no root situation. So again, there are two conditions. So do not confuse with a quadratic function being negative and discriminant being negative. It is implying different thing. Discriminant being negative imply no roots. quadratic function being negative implies that the whole graph is below the x-axis. So you have to take notice which one is negative. Is it the quadratic function that is negative or the discriminant being negative? So let's look at the example here. So in this question, we have a quadratic function, and the quadratic function is always positive. Okay, so which situation does it fall under? So it falls under the first situation. So for this to be always positive, the implication will be the graph of this will be entirely above the x-axis. So that is the first situation. So this will be the first situation, this will be the second situation. So there are two conditions for the first situation. So in our case, right, you explore the A, B, and C. Okay, so the condition says that A has to be positive. So the first condition will be K needs to be positive. And the second condition says that the discriminant has to be negative. Because the graph is entirely above the x-axis, so there is no roots. That's why the discriminant is negative. So put in your ABC. So put in your ABC. Solve it normally. Okay, remember to reverse the sign because you're dividing by -12. So you got two inequality. So you're going to combine the two inequality. So combine, if I want to combine the two inequality, it is like doing it on a number line. So k greater than 0 and k greater than 4 and 1/12. So eventually, my final answer will be k greater than 4 and 1/12. Okay, so that will be the condition that you need to know. Again, it will be quite repetitive if you can distinguish between quadratic function being positive versus discriminant being positive. So when a quadratic function is being positive, we are implying about the graph always above x-axis. That's why you got no roots, and the no roots part leads to the discriminant being 0. Not being 0, the discriminant being negative. Okay, so let's talk about the second type of question. Okay, so if you look at example 2, I got a quadratic function that is always negative. So the implication will be the graph is below the x-axis. So that is the second situation. It's completely below the x-axis. So you go back to the second situation. So the graph is entirely below the x-axis. So the condition will be A being negative and the discriminant being negative. So we're going to explore first. I'm going to explore the ABC first. So for the condition to happen, so for this to be always negative, meaning right, the graph is always below the x-axis. Okay, A must be negative and the discriminant must be negative. So put in your ABC. So in such a case, I write something wrongly. This should be a C. So you work it out carefully. You are dividing by a -4. So remember to reverse the sign. So that will be the two conditions. So the question asks, what condition must be applied? So the conditions to be applied are A must be positive, and the product of A and C, sorry, A must be negative, and the product of A and C must be more than 25. So usually, the second part, they will ask you to give a numerical value. So a lot of people couldn't give a numerical value correctly. Okay, so what is the implication of the condition? A must be negative. Well, you can choose any negative number. So A is a -2. So I'm choosing it to be a -2. And I got to choose C in such a way that when I multiply, the product will be more than 25. So mentally, you got to choose a number C so that when you multiply by your -2, it will be greater than 25. So I'm going to choose a -20. And if I would like to check, I will be checking the product. So I chose a -2 for A and I chose a -20 for C. So when I multiply them, I actually get a 40, which is more than 25. So these two sets, this is a possible pair of answers. There are more than there are a lot of possible answers. So you do need to check that it actually match. So this is one of the O-level questions, and it is typically keep repeating in a lot of exams. Okay, so make sure you understand the condition. So it's something for you to take note. Later on in the next few portion of this topic, we will come back to this condition again.